Welcome back. In this video, I will discuss single linkage agglomerative hierarchical clustering with the help of a simple solved example. In the previous videos, I have solved many examples on agglomerative hierarchical clustering. Link for those videos is given in the description below. In this case, we have been given a data set with 5 data points, that is A, B, C, D, E. Also, the distance matrix is given to us. That means the distance between a pair of data points is given. Given this data set, we need to use the single linkage hierarchical clustering algorithm, and we need to divide this data set into different clusters here. And then we need to draw the dendrogram in this case. Because we are using single linkage agglomerative hierarchical clustering, we need to use the minimum distance formula to update the weight matrix. To calculate the minimum distance between two clusters A and B, we can use this formula. That is, distance between cluster A and B is always equal to the minimum distance between the data points within those two clusters here. Now, I will discuss this formula at the later stage once you merge the two data points into one cluster. Now, we will start with the initial data set. The data set contains 5 data points. We consider each of these data points as the initial clusters or the singleton clusters. The meaning of this one is initially we have 5 clusters here. Now, what we need to do is we need to identify in this case, we need to identify two clusters whose distance is minimum. For example, if you look at this cluster A and cluster B, the distance is 9 here. Similarly, we have to go through each and every distance. The one which is having minimum distance, those two clusters should be merged with one another. If we closely observe this distance matrix, we have a distance 2 between E and C, which is minimum among all other distances here. The meaning of this one is we need to merge the cluster E to cluster C in this case. Now, once you merge E to C, it looks something like this. Now, after merging, we have 4 clusters because we have merged E to C in this case. Now, one more thing we need to note here is we know the distance from C to all other data points. That is what you can notice here. We know the distance from E to all other data points, but we don't know the distance from CE to all other data points here. So that's the reason what we need to do is we need to calculate the distance from cluster CE to A, B as well as D in this case. To calculate the distance between cluster CE and AB, D, we need to use the minimum distance formula. That is, we need to use this one. Distance between cluster CE and A is always equal to the minimum distance between CA and EA here. We know the distance between C and A, that is equivalent to 3 here. The distance between E and A is equivalent to 11. Between 3 and 11, 3 is minimum here. The meaning of this one is the distance between cluster CE to A is equivalent to 3 here. Similarly, we need to calculate the distance from CE to B here. That is nothing but the distance from C to B, and then the distance from E to B we need to identify. Between those two, we need to get the minimum here. The distance between CB is equivalent to 7 here. The distance between EB is equivalent to 10. Between these two, 7 is minimum here. With the same note, we need to calculate the distance between cluster CE and D here, which is equivalent to 8 in this case. Now, once you get the updated weights, we need to put it over here. We will get the updated distance matrix here. Now, once you get this updated distance matrix, that will be considered as the distance matrix for the next iteration here. Now, again, from this table, we need to identify the two clusters whose distance is minimum here. And if you notice this distance matrix carefully, the distance between cluster A and CE is 3, which is minimum among all the distances here. The meaning of this one is we need to merge the cluster CE to A in this case. Now, once you merge this CE to A, we will get the 3 clusters. The one cluster is ACE, B is the another cluster, and D is the another cluster. That is what you can notice from this table here. Again, we don't know the distance from ACE cluster to B and D. We need to calculate these two distances here. To calculate the distance, again, we are going to use the minimum distance formula. The distance between cluster ACE and B is always equal to the minimum distance between A to B, C to B, and E to B here. So we know all these distances and we need to get the minimum among these things. The minimum among these distances is equal to 7 here. The meaning of this one is the distance from ACE to B is equal to 7 in this case. Similarly, we will calculate the distance from cluster ACE to D here. That is nothing but the distance, minimum distance from A to D, C to D, and E to D here. We know all these distances, that is 6, 9, and 8. Minimum among these three is 6 here. So the distance between cluster ACE and D is equivalent to 6 here. We will update this weight matrix. This is how the weight matrix will look like after updating. Now we need to consider this as the weight matrix for the next iteration. Again, we need to look for the distance which is the minimum between the two clusters here. And if you look at closely, the distance between B and D is equivalent to 5. That is the minimum among the distances over here. The meaning of this one is we need to merge B and D into one cluster here. Now, once you merge B and D into one cluster, we will get only two clusters here. That is ACE will be the one cluster and BD will be the another cluster here. Again, we don't know the distance between B comma D, that is one cluster, to ACE. We need to calculate that distance over here. To calculate that distance, again we use the minimum distance formula. That is nothing but the distance between cluster ACE to cluster BD here. That is nothing but the minimum distance between AB, AD, CD, CB, EB, and ED. I have written all those possibilities here, and then we need to put the values. Minimum among these things is 6 here. The meaning of this one is the distance between the cluster ACE to BD is equal to 6 here. This is also 6 and this is also 6 here. Once you update this weight matrix, the weight matrix looks something like this. Now we need to consider this as a base weight matrix for the next iteration. In the next iteration, there is no need to look at the minimum distance because there are only two clusters are there. We will merge these two clusters with one another, and there is no need to update the weight matrix also. Because there are only two clusters are there, we will merge it and we will get only one cluster containing all the data points in this case. Now, once you get all data points into one cluster, we will stop the single linkage agglomerative clustering algorithm, and then we will start building the dendrogram in this case. To build the dendrogram, we need to draw the lines between the clusters which were merged first and in that sequential order here. So in the first case, we have merged C and E. So that is what you can notice here. After that, we have merged A to CE. This is what you can notice here. Later, we have merged B and D with one another. And finally, we have merged ACE and cluster BD here. That is what you can notice over here. So this is how the dendrogram for the given data set looks like with respect to single linkage agglomerative clustering algorithm here. Now, once you get this dendrogram, based on the required number of clusters, we can cut this dendrogram and then we will get the number of clusters here. For example, if I cut this dendrogram over here, we will get two clusters, one cluster containing ACE, another cluster containing BD here. If you want more than two clusters, let us say that I am interested in three clusters. I will cut the dendrogram here. We will get three clusters containing ACE as the one cluster, B will be the another cluster, and D will be the another cluster in this case. So this is how we can apply the single linkage agglomerative clustering algorithm on the given data set. And then we can merge the data points into different clusters, as well as we can draw the dendrogram. I hope the concept of single linkage clustering algorithm is clear. If you like the video, do like and share with your friends. Press the subscribe button for more videos. Press the bell icon for regular updates. Thank you for watching.